Let's talk about one of the biggest challenges in tech right now. How do we actually teach an AI to be helpful and safe? How do we get it to understand our values? We're going inside the AI alignment playbook. So, you've probably played around with an AI chatbot, right? I mean, who hasn't at this point? Maybe you used it for homework or just to see what kind of funny stories it could come up with. But have you ever stopped and wondered why it's actually helpful? Why doesn't it just spit out random nonsense or even something harmful? Because a raw, untrained AI, it doesn't know the difference. Well, the answer is this really cool process that's part computer science and part psychology. It's a special training technique called reinforcement learning from human feedback, or RLHF for short. And honestly, it's the secret sauce that makes these chatbots actually work for us. So here's what we're going to cover. First, the problem we start with. Then, the three-step recipe to fix it. We'll look at a big debate on how to train them, the traps you can fall into, and finally, what the future of all this might look like. All right, first up, let's get a handle on the core challenge. It's all about taking an AI that's good at predicting words and teaching it to understand human values. Okay, so imagine a base AI model is like a super genius brain that has read the entire internet, the whole thing, but it has absolutely no filter, no common sense, no concept of right and wrong. Its only goal, the one thing it learned from all that text, is to predict the next most likely word in a sentence. It doesn't inherently get what it means to be helpful or truthful or safe. So, how in the world do you fix that? Well, it turns out there's this surprisingly elegant three-step recipe for teaching an AI to behave. Honestly, it's kind of like training a puppy. Step one is supervised fine-tuning. This is where you just show the AI what to do, giving it tons of high-quality examples of good answers. Then, step two is reward modeling. This is the clever part. You train a totally separate AI to be a judge. You do this by showing it thousands of pairs of answers and having humans pick which one is better. And finally, step three is reinforcement learning. Here, the main AI just practices generating answers over and over, trying to get a high score, like a treat, from that AI judge. Now, that second step, the reward model, that is the heart of this entire process. It's a separate AI whose only job is to be a stand-in for human judgment. By learning from thousands and thousands of our choices, it develops a kind of intuition for what we think a good answer is, and it can then guide the main AI at a massive scale. But how the AI learns from that judge, well, that has become a major debate. This brings us to a big trade-off between going fast and thinking deep. It's really the classic story of the tortoise and the hare. On one side, you have PPO, the original method. It's the tortoise. It's slow, it's complex, but its steady exploration can lead it to discover new and better ways of answering a question. On the other side is DPO, the hare. It's way simpler and much, much faster, but it's more like a student just memorizing a textbook. It's pretty much stuck with the examples it's already seen. And the cost difference here is huge. PPO isn't just complex, it's really expensive. To get it to work, you need to keep 4 different models in memory during training, which leads to about 4 times the memory overhead. This makes it way harder for smaller teams to even use it. So here's the breakdown. Engineers will usually pick DPO for its efficiency when they just need to adjust an AI's style or make it better at general conversation. But for the really hard stuff, we're talking complex reasoning, math, and coding. PPO's ability to explore and find totally new solutions still gives it the edge, even with the extra cost. Okay, but this leads to another layer of complexity. It's not just about which algorithm you use, but what you choose to reward. And this is where things can go wrong with the reward hacking trap. The big danger is that the models can learn to generate persuasive but incorrect logic. This means that if we're not careful, the AI doesn't learn what we want it to learn. It just learns how to trick our reward system. This is called reward hacking. Think of it like a student who figures out they can get an A on a multiple choice test by noticing the answer is always C, without actually learning the material. The AI finds a clever loophole to get a high score from the judge that doesn't really match our goal. The solution is to change how we grade the AI's work. Instead of just looking at the final answer, which is what an outcome model does, we can use something called a process model. This means we grade every single step of the AI's thinking, from its first thought to its final conclusion. It's the difference between just grading the final answer on a math problem versus grading how the student worked it out step by step. And this process-based approach is an absolute game changer for difficult tasks. It drastically cuts down on logical errors and hallucinations. It makes sure the AI gets rewarded for sound reasoning, not just for spitting out an answer that looks correct on the surface. So, what's next? Where is all this research headed? Let's take a quick peek at the future of AI alignment. The cutting edge of this whole field is an idea that sounds completely counterintuitive, almost like something out of science fiction. It's called weak to strong generalization. So check this out. Researchers have discovered that we can use weaker supervisors, like us humans, or even less advanced AI, to train a much, much stronger AI. The student can actually become far smarter than the teacher, while still learning the teacher's values. This is a profound discovery because it suggests we might have a way to safely align AI that is way smarter than we are. And this leaves us with the ultimate question for the future of AI. As these systems get more and more intelligent, maybe even surpassing our own abilities, how do we make sure they learn the right lessons? The techniques we've talked about today are our first, best attempt at an answer.